It is impossible to freeze helium. There are a few factors that come together to make this possible. For example, if you have a tank of helium, just any old helium, helium atoms are held together by very, very weak van der Waals forces. It's very, very easy to break van der Waals forces. Helium also has a very, very big 0-point energy. I won't go into what that means now, but basically 0-point energy is kind of like the absolute minimum energy something can have. In quantum mechanics, nothing can have exactly zero energy. There is like a smallest amount of energy, and that energy is inversely proportional to the mass of something. So small mass means big energy. Helium is very small mass, so it has a big 0-point energy. You put all those things together, it's very difficult to get helium to be a solid. The only way to do it is to put it under crazy pressure, like you've got like, you can't freeze it in the normal sense, you know, in the way that you'd freeze water, like you just make it colder and it solidifies under its own vapor pressure. You can never do that to helium, which leads to some pretty interesting phenomena. What you can do to helium, if you cool it down to within a few degrees Kelvin, is you can make it a superfluid. So that is kind of like a liquid, except it has zero viscosity. So it has zero thickness. Viscosity is like the thickness of a liquid. Like honey would have a very, very high viscosity. Water would have a lower viscosity. Liquid helium, superfluid helium, I should be more precise, has zero viscosity. So if you stir it, it just keeps going forever and ever and ever, just like woo, like literally, like you can look up videos of people stirring liquid helium and it looks really weird because, you know, like if you stir a coffee cup, the coffee will spin for a little bit and then it'll eventually slow down and stop. But superfluid helium doesn't, it just keeps going. It's really weird looking. It's a fun one.